the biggest thing I wanted you to get from 10-1, if you can find the greatest common factor of a set of terms, that's really the biggest part of 10-1. And that's going to be necessary when we're dealing with 10-2 and on. Your first step is to always get the greatest common factor out of the expression. So go ahead and write this down. This little problem right here. Does this problem look familiar to anybody? Did you guys do this, some type of problem such as this one on Friday? Yeah, there are no exponents, thankfully. This would have been an easy one. But yeah, you've done this before. Go ahead and multiply that out, please. So I want it to be simplified. So to make it simpler, I need to drop those parentheses, but I have to do that using which property? Good, distributive. So what's 3 times 2a? 6a. And what's 3 times b? 3b. Okay, good. So if you can do that, you're on a good path so far. I want to ask this question here. What is the greatest common factor of these two terms? What's the GCF of 6a and 3b? Josh?
3.
It's 3. The GCF of these two terms is 3. Okay, do another one here for me. 5x times 3x minus 4y. Multiply that out, please. 5x times the quantity, 3x minus 4y. So 5x times 3x is good 15x squared. And then 5x times negative 4y. Negative 20xy. So that's basically last chapter. And so now I'm going to apply it to this chapter. How many of you got 15x squared minus 20xy? Okay. What's the GCF of 15x squared at negative 20xy? 5x. It's right here. Okay. What we're doing here is chapter 9. Yeah, chapter 9 is right here, where you just multiply, right? You just had to multiply these two and get the right product. Chapter 10 is taking this expression or this expression and writing it as a multiplication problem. So this case, this is addition, that's addition. But now I have to write it as a multiplication problem, and that's the whole point of factoring. Factoring is writing a problem into multiplication, okay? So let me give you another example here and see if you guys can do it. So here I get 3x squared plus 15x, all right? Is this a multiplication problem? I guess you could say like these are being multiplied and those are being multiplied, but overall what kind of problem is this? It's an addition problem. I want to write it as a multiplication problem. So the way to do that is to find what's the GCF of 3x squared and 15x. What's the GCF? 3x. Okay? And then in parentheses, this is how you're going to find those two terms inside. 3x times what equals 3x squared? X. 3x times what equals 15x? Positive 5. This right here is the factored form of this expression right here. Okay? It is cool. It's really cool. And it's kind of funny because we're going to go back and forth. It's going to, okay, nice, we could do it. But doing this process of factoring, going backwards, is actually going to help me to make expressions simpler. Okay? It may not look like it now because we're not doing that per se, but going from here to here makes it simpler. And you're going to see little by little that that's the case. Yes? On the last problems you said, like right here?
What if you get like a different factor, like out from the product?
The way I can come up with different factors for these two numbers, like this number, that number, is if I don't get the GCF, I just get a common factor. Like if all I took out was a 5, I'd be left with two different numbers here. I'd be left with 3x squared and negative 4xy. So that's a way to get something different. But I'm going to put a little note for you guys to help you realize there's a certain way we want to do it. And that'll help us to get the GCF out. Okay, so let me get this note down because it actually goes with what you're saying. To factor, so if you're like, what does, I keep using this word factor, but to factor means to express as a multiplication problem. And there's a more technical definition, but I was thinking, like, how can I make this so where we can communicate it and still be accurate with our answers? So do you guys see, if I started off with this expression, this sum, and I write it like this, do you see how I express it now as a multiplication problem instead of just an addition problem? That's factoring, okay? That's what it means to factor. And we're going to do a lot of that today. Okay, let's look at example 1a to see how our problems come out. So I'll give you a little bit of time to write this out. But example 1a. Okay, I'll go back in just a moment if you need it. 12mn squared minus 18m squared n squared. Okay, and just make sure you write it correctly because if you don't, you're going to factor something different that wasn't necessary or wasn't even there. Okay, is this a multiplication problem?
Yes. Sort of.
Yeah, and overall, is this a multiplication problem? No, it's an addition problem, okay, with the negative number there. So I need to factor out the greatest common factor. Does anyone know what the GCF between these two? 6m n squared. You're like, how did we get that? Let's look at it. In your homework, you had to break it down into prime factorization. On a lot of these problems, you could look at it. But look at the numbers between 12 and 18. What's the greatest common factor of 12 and 18? 6. 3 goes into it, but the greatest number that goes into it is 6. 6 goes into both of those. Okay, how many m's are being multiplied in the first term? 1. And on the second? 2. How many do they have in common? 1. So that's how I have m to the first. 2 n's are being multiplied here. 2 n's are being multiplied here. So how many do they share in common? 2. And n to the second power. Okay, then I'm going to start my parentheses, and this is what I'm going to do. 6mn squared times what gives me 12mn squared? 2. Yes, just 2. And on these problems, you know what? Every single one of them can be checked by you. Like you can run through it multiplication and see if you get the original expression. 6mn squared times what gives me negative 18m squared n squared? Negative 3m. All right. Is this in factored form? Well, is it a multiplication problem? Yes. And this is actually more alluding to, I think, a couple of your questions. This is a multiplication problem, but I have to ask, do these two numbers in parentheses have any more common factors? Like, is there anything else that's common between these two? No, just one, right? So no other factor but one. So this is called completely factored, and this is how I want your answers. So let me give you a note on that because sometimes we don't completely factor. To completely factor, which is what we want to do in all these problems, means to leave no common factor in each term inside the parentheses. Sorry, those got sloppy at the end. So before you go ahead and circle and you're like, oh, I got it, move on because you checked it and it works, you have to look at these two terms or three terms or whatever and say, is there anything else that's common between these two inside? Nope. Now you're done. That's completely factored. And that's what we want to do. Yes, sir?
Is there a scenario where that actually can happen?
Yeah, like where I don't do this? Yeah, like I would get, oh, go ahead.
Not.
Like if I did this problem, I did this. Let's say 6mn. I mean, I could get 2n minus 3mn. Okay, is this factored? Yes, it is made a multiplication problem, but is it completely factored? No, because you see how they both still share an n? So I need to factor out that n and make it 6mn squared times 2 minus 3m. That's completely factored. So don't leave it partially factored. I want it completely factored.
Okay.
So are there any more terms? Are there any other common factors here? Nope. Were there common factors here?
Yeah.
So this was not completely
So it
factored.
has to be
This.
between variables.
Variables and numbers.
Oh, numbers.
Yeah, the numbers too. Like, is there anything else that fits into 12 and 18? No. So that's it. Or you could have also done 2mn, and you still could have factored it, but not completely. Good questions, because yeah, I'm going to grade on that as well. Okay, let's do B on this one. 20abc plus 15a squared c minus 5ac. Uh-oh. Lot to do here. How many terms are up there? 3. That's called what kind of polynomial? Trinomial. Okay, and that means something for my answer, by the way. But looking at the numbers, I'm going to start calling some people. Walker, what's the GCF of just the number parts? What's 5? What's the GCF of the variables? Ellie? A and C. Okay, I'm going to check this out. All right, looking at the numbers, is 5 the GCF of 20, 15, and negative 5? Yes. But A, they all have A. This one has 1A, that one has 2 A's, and that one has 1 A. So how many A's do they share in common? 1. What about the B? What happened to the B? That one has a B. But they don't all have a B, so it's not a common factor. And then they all do have 1 C. So this is the GCF of those 3 numbers, right? And that's what you did this weekend? Or this past weekend? So that's the point of that lesson. Okay, somebody tell me what goes in this blank right here, this first blank. Benton? 4B. And you're like, nice guess. I don't know how you're supposed to figure it out. You can check yourself instantly. What's 5AC times 4B? 20ABC. That works. Eli, the second term. Plus 3A. Oh, good guess, but let's check it. 5AC plus 3A? 15A squared C. That works. Very good. Last term. Katie? Negative 1? Hold on. What's 5AC times negative 1? Negative 5AC. That works. That is the expression. Is there anything common among these 3 other than 1? Nope. Is this completely factored? Yes, it is. Can you check it? Of course you can. All of them can be checked. Yeah, the binomials can be checked with FOIL. This one you can just do these 2, and those 2. Yes, ma'am? Oh, sir?
What if there was one that was like common among 2 of them, but not the other one? Like it was
So like these 2?
4, 8, and negative 1.
4, 8, and negative 1. Yeah, there's nothing common among all 3 of them, so you can't factor out a 4. Yeah, good question. You guys good on this? How many of you are like, okay, it's not too bad? Just a few. Okay, let's get some practice. On page 569, do number 7, and oh my. You remember your test? I graded them last night. I started grading them off, and I was like, yes, let's get this done. And as I'm grading that first page,
Did you have a bad dinner?
I had a terrible dinner.
Oh.
I had nachos. It was good. But that's what got me started off on a good note. But you know something I noticed, and this is why I want to help you out. Let's just keep working on it. What do the instructions for number 7 say to do? Find the GCF of the terms in each expression. Do they want you to factor it?
No.
Do they want you to write it as a multiplication problem? No, they just want the GCF. So on number 7, go ahead and try that out.
Wait, so what you're saying on our test we didn't like.
Some, not everyone, but yeah.
Like we didn't read them.
Some did it. Yeah, it's like write it in scientific and standard.
Was that a problem again?
Write in ascending order.
Ooh.
Oh yeah.
What type is it?
Oh.
It's like, and this is, I'm like, I don't, okay. But just read the instructions. I want to help you out. I'm doing that not to be like bad for not reading. No, I want to help you on your tests because you miss points. And you will have more of those. Okay, yes, sir.
What happens if we get a problem like
Number 9.
Oh, yeah, number 9.
One.
Yeah, the GCF is 1. Yeah, and so that, on that one cannot be factored anymore. That's it. That's all you're left with. Or you could say 1 times 5a plus 3b, but we know that's 5a plus 3b. That's okay. You're excited. And that's good because I want the answer to this one. What's the GCF, Benson? Sorry? 3. That's the answer. That's all I wanted. All right, do number 12, please. Everyone, number 12, find the GCF of 4x squared y minus 6xy squared. What's the GCF of that? I just want the GCF. Yeah. Yeah, so can both of the do both? What, does 3 fit into both of these? Like does 3 fit into 3? Mm-hmm. Does 3 fit into 12? Mm-hmm. Does any other number fit into both? Like any other number? No.
Okay,
And then
what about the y's?
Yeah, if this has a y and this has a y, you can factor out a y.
Okay.
But they both don't have y, so the GCF is just 3.
Okay.
Like if this one had a y to the first, the answer would have been 3y.
Okay.
But it changes. Okay, what's the GCF y of 4x squared y and negative 6xy squared? 2xy. How many of you got that? Okay, if you could do this problem, you could do these next problems. Number 19, factor each polynomial. Do I want a multiplication problem here?
Yeah.
I do. I want a multiplication problem, and I want it completely factored, not partially. 19. Same page.
No. Sorry, not this one, please.
Yes.
No.
And there's more to come. 19. Okay, James, what's the GCF of these two? 1. Okay, 1 is the numerical part, but anything with the variables? X. Don't they both have X? So X comes out. What's left in the parentheses, Josh?
29y minus 3. We're good. Oh yeah.
Don't break that. Okay. How many of you got this? Anything else that can go into 29y or 3? No, that's it. That's completely factored. So we're going to leave it like that. And then just do number 20. See if you can get that one, and we'll move on. Okay, Harper, what's the GCF of these two terms? So this and this. x. Vivian, do you know what's left in the parentheses? Minus 1. That's it. Completely factors right there. Guys okay with those? Does this seem pretty straightforward, a little bit easy there? Good. That's the first half of the lesson. Second half. Factoring by grouping. Dun dun dun. Okay, you guys did well so far, and if you could do the first part, you are very well set for the second part. Go to example number 3. What do you notice about example number 3? It has how many terms? 4 terms. That's interesting. Okay, 4 terms. What's the GCF of those 4 terms? Yeah, no problem. Take your time there. What's the GCF? 1. Oh, can you factor that anymore? Not yet. This is called factoring by grouping. When you have 4 terms, you can group them together. This is what you're going to do. I want you to group these 2 together and these 2 together. And we're going to factor not once, not twice, but 3 times. And this is how it's going to work. When you're grouping, listen carefully. When you're given 4 terms, you want to have 2 pairs of 2, and the pairs just have to have any common factor other than 1. So do these 2 have a common factor other than 1? Yep. Do these 2 have a common factor other than 1? Okay. So what's the GCF of just these 2? Let's just factor those 2 first. 3a. And then what would be left in the parentheses? 4c plus 7d. Do you guys agree with that?
Yeah.
Okay, I'll pause a little bit just so you can catch up if you're still writing this down. And then we're going to factor out the second 2 terms. So I'm going to look here at these 2 terms and ask myself, what's the GCF of 8bc and 14bd? 2b. Yes, 2b. And then what's left in parentheses? Oops. 4c plus 7d. Whoa, what? What? Uh-oh. Okay, before we move on, listen carefully because this is a tricky part. What's going on between these 2 and these 2? Addition. So I'm going to leave it like that. By the way, this actually affects you on the last type of problem. I technically could have taken all of this and moved it over here. Isn't that allowed? If they're both being added, I could just take all that, move it over there. That's going to mean something later. Not always. Yeah. Okay.
Wait, does this mean that
If this is being added with this, I could just rearrange them. And that does make more sense later. How many times have I factored so far? Twice. We're going to go one more time. Watch what we're doing. What's common between these 2 terms? 4c plus 7d is the common factor, isn't it? What would be left in parentheses? 4c plus 7d.
3a plus 2b?
3a plus 2b. And you could have written it a little bit differently, but that's it. That's factored form.
The answer?
Yep.
You don't have to do 4?
Oh, okay. Here.
No.
You have to check it.
Okay, you can check it by 4, but you don't have to. Yeah, listen carefully, and if I can get your attention, this will help you out. Okay, do you guys see we have one expression here and one expression there, and that they're being added? So it's basically this is actually a binomial, 1 term, 2 terms. Is there anything common to both of these? Any common factors? 4c plus 7d? Yes. So I'm going to factor that out, and what was left behind? 3a plus 2b, 3a plus 2b. Now, I'm kind of like guessing here, because I'm like, well, I hope they believe me, because who's going to prove me wrong? You can prove me wrong right now. Can you check to see if this is correct?
Yes.
All right, what's 4c? We're going to use FOIL. What's 4c times 3a?
12.
12ac. What's 4c times 2b? 8bc. What's 7d times 3a? 21ad. What's 7d times 2b? 14bd. Do we get the originals?
Oh, good.
It's triple. It's basically you're factoring 3 times. One time here, and then a third time right here.
That was good.
It is cool because it does work out a lot that way. How? It's a factor.
How
Yeah.
come you can like combine the two together even though each side of them being added?
Well, it's the same thing as here, right? Look at this. What's going on between this and this? Adding. So couldn't you factor out the 3a, leave it like that? You did that there. These two are being added. You did it here. These two are being added. You're doing the same thing. It's a slow experiment. It is complicated. Okay, Walker.
So you said this doesn't always happen.
Oh.
Because it's Swivl cottage, right? So, yeah.
Don't listen to him.
Okay.
Go ahead, Walker.
So what happens when it doesn't happen?
You could call it prime. That means it can't be factored anymore. But I wouldn't worry too much about that.
We're not having to do this one?
Not today.
That's
No.
the Friday quiz.
We have a quit. Oh, yeah.
Someone looked at the board. Oh man, imagine that. On Friday, there's a quiz. That's worthy of an applause. So I changed it this morning. I'm thinking, I wonder who's going to notice. Last class, no one said anything. Maybe they noticed.
Yes, Walker.
Today? On Friday? We can.
Oh,
Yep.
so all the spells, do we have it like every time?
Every Friday? Yes. Yes, unless if I don't mention it. So I'm making it available this week. So yes, you will have it Friday. Okay, let's do another one just to make sure we're getting it. On page 569, and I want to move here so you guys can have some time for your homework. Number 23. So stay with me, guys, because the time's going to run out. You won't have much time on your own. I know you have a lot to do here. And again, make sure you write it correctly because that will throw a lot off. Okay, what you want to do is you realize how many terms do I have up here? 4. So I can factor by grouping. Just make sure that these two right here have a common factor and these two have a common factor as well. If they don't, just rearrange them so that that is the case. And you're allowed to rearrange addition. What's the GCF of Rx and 2Ry? R. So I'm left with x plus 2y. That's the first factoring. Yep.
So couldn't you do like Rx and then 2Ry and 2K?
What are you trying to find a common factor in all of them, or
No, like you partner 2Ry and 2K.
you could have partnered those two together?
So
Yes.
Can you partner any together?
You can partner any two that have a common factor. So you could have
At least
done,
one?
huh? At least one.
Okay.
But what if we did 2RY and KX?
That wouldn't work because it's only one, and that's not going to help you out. So you got to partner them up with something else. So you can partner them. You can change the partners as long as they have a common factor. And this one here, you get k and then x plus 2y. And then what am I left with at the very, very end? Margot?
Me?
Yeah.
Like me? Okay, hold on. Wait, what am I left at the
Yeah, what's your final answer? You know?
Okay. Do I have to like factor them out?
Yeah.
Oh, R. You combine.
You could do x plus 2y.
Oh.
And then what's the second one? So you factored this out of both of them, and you're left with,
It's just like X plus 2Y.
yeah, the x plus 2y,
R-O-R-K.
r plus k. That's what you get. And can you check these guys?
Yes.
Yeah, use your foil. You can check it out. Okay. Last problem, and I'll let you go. final, ultimate last one. This one's the toughest one out of them all. Try out example number 4, please. And you keep going as far as you can, but please don't assume something because signs matter. All right, 4 terms. I can factor by grouping. In fact, just the way they are, I can factor them. So I'm going to go these 2 and those 2. So here I'm left with 3x. So I got 5 minus y. Do you guys see how I got that? I factored out the 3x. I'm left with 5 minus y. Okay. Second 2, I'm going to get, I factor a 4 out. I'm left with y minus 5. If you want to keep going, you better stop. Because I can't just do what I did in the last problem because there's a critical difference.
Different.
Are these 2 exactly the same? No, in fact, they're opposites of each other. So you don't, not reciprocals, they're additive inverses. So you can't just factor out a 5 minus y or a y minus 5 because they're not the same thing. But can I change them?
-1 maybe.
Okay, I'm going to multiply one of these by -1. And usually, listen carefully, I want to get it in this form where the variable plus or minus the constant. So here, I'm going to change both of these signs. This is positive, that's negative, right? If I multiply this right here by -1, I can do that. I'm going to get negative 3x times negative 5 plus y. And you're like, I mean, you can't just do that, right? I'll show you why you can do it in just a moment. So just write that down, and you're like, But do you notice here, this doesn't look the same way as that, but can I change it? Yeah, just put y minus 5 here. Now can I factor it out? Why am I even allowed to do that? Here's the little concept. Ready? Do you guys remember stay, change, opposite? Okay, please stay with me here so I can help you out. The original problem was this. Do you remember when I said I can take this right here and move it over here? Okay? Do you remember that? I can move all of this and take it over here. Stay, instead of adding, subtract, opposite. Ready? Stay, all normal. Change, opposite.
That's pretty fancy.
That's the reason you can do it. So if you didn't understand that, it's okay. Just multiply everything on one of them by -1. That's basically what you have to do. And so now can I factor something out? The numbers don't lie. Have you ever heard that? Unless we're using them and then.
Warriors. Whoa.
How can I write the second part? I got y minus 5 times. How can you write it? You can say negative 3x plus 4 or 4 minus 3x. Either way is fine. They're both correct. That's your answer. So be careful. Okay, your homework tonight. Yes. Yes. No. You're getting there.